When we look at a data set, we have to be aware of the spread. How dispersed are the data points? These are called measures of dispersion. Let's take a look. So dispersion is the degree of variation in the data, and we can measure it using range, interquartile range, variance, or the most useful, the standard deviation. Why is this important? Because when we calculate the mean, the median in the mode, we are trying to find out the central measure of location, but that doesn't tell us how spread or compact the data is. So in these two examples, you see that the mean, median, and mode are similar or the same in both graphs. However, in this graph, the data points are more compacted than in this other one, in which they're more spread. If we don't pay attention to this, we could make incorrect decisions. Let's take a look. Assuming that the average household income for Guelph is $95,000 and for Hamilton, $98,000. Again, this is just an example. If we were an entrepreneur and we want to set up a new car dealership, but we want to set up their dealership in a town or a city that has a household income above 95,000. Which one would you say? Well, we might be tempted to say, well, let's focus on Hamilton then. But without looking at the dispersion, we could be making a mistake. If we knew that in the case of Hamilton, yes, the average is $98,000, but notice that it's very spread out. Again, this is just an example. You can see that there are some households that have very high income, and therefore they're bringing the average up to $98,000, but that most of the household actually earn less than $90,000. On the other hand, in the wealth case, we see that the spread is less dispersed. And here, most of the household actually make above $90,000. So if we just pay attention to the average, we could be making a mistake. When we pay attention to the average, the median, the mode, and the dispersion, then we can find out what is the best town for a car dealership. I mentioned several measures of dispersion. Range is the simplest one and is the difference between the maximum value and the minimum. The range is affected by the outliers, and it's often used only for very small data sets. Another measure that is not influenced by extreme values is the interquartile range. It's also called the mid-spread. We're going to practice how to calculate it. We use quartile number 3 minus quartile number 1. Then we have the variance. The variance is the average of the square deviations from the mean. We seldomly use the variance. What we use is the square root of the variance, which is called the standard deviation. And in Excel, since most of the time we'll be working with the sample, the formula that we use is stddev.s. Before I tell you the importance of the standard deviation, let's do some calculations. Using our purchase orders data set, we can calculate the range, which will be the maximum value of the data set, in this case, the cost per order, minus the minimum value. $127,431. The quartile, which is not affected by outliers, would be calculated using the quartile functions. So it will be quartile number 3. Remember that we're using quartile.inc as for inclusive, minus quartile number 1. I'm just going to input the numbers. Now we have 20,000. You see the difference between using outliers or extreme values and not using extreme values. Now the standard deviation. We use stdef.s because most of the time we'll be working with sample. If you're working with a population, we'll be using P. 29,000. Okay. And we're going to calculate the mean. Why? Because the mean gives us a lot of information when used in combination with the standard deviation. Let me get back to the presentation and then we'll go back again to Excel. So we established the range, which was about 127,000, the interquartile, which was about 20,000, and the standard deviation, which was 29,000. Why is the standard deviation so useful? Because of these empirical rules that we will revisit later on. For many data sets that we're going to encounter in practice, we can apply these rules of thumb. Because most of the time they will follow a normal distribution, we can say that approximately 68% of all the observations will fall within one standard deviation of the mean. What does it mean? Well, we have the mean in the center, right? One standard deviation to the left, one standard deviation to the right. 68% of the observations will fall within this range. 95% of the observations will fall within two standard deviations to the left and two standard deviations to the right. 99.7, 98% will fall within three standard deviations. This is important because just by having the average and the standard deviation, again, we can learn a lot from our data set. Let's apply it in Excel. So how do you calculate that? We only use the average, the mean, and the standard deviation. So 68% of the data will fall between one standard deviation. So that would be the mean minus one standard deviation and the mean plus one standard deviation. It gives us a minus, a negative value. Well, because the cost per order cannot be a negative value, we can assume that it's 0. So this says that 68% of the data is between 0 and $56,138. 95% of the data will fall within two standard deviations to the left and two standard deviations to the right. So we would take the mean minus standard deviation multiplied by 2, and then the mean plus the standard deviation multiplied by 2. That means that 95% of the data will fall between 0 and $85,980. And finally, the third empirical rule, that 98% of the data will fall within three standard deviations. So that would be the mean minus standard deviation multiplied by 3, and the mean plus standard deviation multiplied by 3. So we can say that 98% of the data will fall between 0 and $115,000, 823. We'll have other uses for the standard deviation, but that's probably one of the most common ones.